Okay, in this video, we're going to graph a sine function with frequency and phase shift. We're going to graph tan. I'm also going to graph just basic cotan and show you the difference between them. And we're going to graph cosecant of x. In another video, I do secant of x. So we'll have all the functions covered. Okay, so sine of 2x plus pi over 4. I'm going to call this number b, and I'm going to call this c. The most important thing to do is know what's going to go in this box, and that's the transformation of the inside of the function. And it's simpler than you realize. What you're going to do is take the inverse of b, 1 over b, which is 1 half, say x. You're going to change that sign, and then take the 1 over b, which is 1 half, multiply it times the c. And what is that? Pi over 8. Okay? If your b is a fraction, if it had said 1 half x plus pi over 4, if your b is a fraction, 1 over b is simply the reciprocal. So 1 over b ends up being 2. That gets multiplied to the c to find the actual phase shift. Okay? So let's fill out the tables. Oh, and by the way, there is, on the y transformation, we're not seeing anything out here, but we just see a +1 here. And so on the y side transform, we're going to just say y equals 1. I filled out the parent table for sine for you. Now the tricky part is going to be multiplying each of these x's by 1 half and then subtracting pi over 8. Well, 1 half times 0 is 0. So 0 minus pi over 8 is just minus pi over 8. 1 half times pi over 2. 1 half times pi over 2. Well, this is pi over 4. And then we have to subtract pi over 8. Well, it helps to do these conversions on the fly. I'm going to force them to have common denominators of 8, so I can subtract the numerators, and I'm going to say 2 pi minus 1 pi is 1 pi. Answer, pi over 8. 1 half times pi is pi over 2. Then I've got to subtract pi over 8. But let's turn this into having pi over 8. Having 8 in our denominator. So that's 4 pi over 8, isn't it? 4 pi over 8 is the same as half a pi. So we end up here with 3 pi over 8. 1 half times 3 pi over 2. Remember, when you're multiplying, you just multiply the tops, multiply the bottoms, minus pi over 8. Well, again, let's do a conversion here. Double that, and we're getting 6 pi over 8. And when you subtract the tops, you get 5 pi over 8. And you can already see a pattern emerging here. It looks like we're advancing each step by 2 pi over 8. This last one, I predict it will be 7 pi over 8. But let's see. 1 half times 2 pi. Notice I put a denominator in there so I keep my fractions straight. It's 2 pi over 2. Again, if I quadruple both sides, I get 8 pi over 8 minus 1 pi over 8 does equal 7 pi over 8. Okay, this is the hardest part of the table work that you're going to be doing, and this is because it involves a phase shift. Y plus 1 should be easy. 1, 2, 1, 0, and back to 1. Just to save time, I'm going to just show you on Desmos the graph that you should plot with your table. And as we said, the beginning of the period is negative pi over 8 to 7 pi over 8. By the way, that is the length of that, negative 1/8 to 7/8. Negative 1 to 8 is 8/8. So the function period is pi. And this is reflected. The amplitude is 1, but it's reflected. And therefore, we're going to see when we start at negative pi over 8 that the graph goes down from the midline instead of up. And then it's the midline again. And then we're going to end up between 3/4 and 4/4, or 6/4 and 8/4 is 7/4. So that's the beginning of the period, and this is the end of the period. And the midline goes right through the middle there. So to fill out a couple more of these, the shift is negative pi over 8. The standard period of sine is 2 pi. And if you divide it by the frequency or take it, multiply it by the reciprocal of the frequency, either way, you get this. Okay, let's talk about tan. I'm just going to do the tables and then show you what it looks like on Desmos. The key thing when you fill out the parent table for tan, and we're going to do the parent table for cotan as well, is knowing the domain. I'm going to use the fancy word for one cycle of tan. Okay, what makes this different is that you travel around the circle from here to here. And you call these angles by using negative terminology, meaning this we're going to call negative pi over 2, that we're going to call negative pi over 4. This, of course, is 0. That's pi over 4. And that's pi over 2. So those are the 5 values. You just have to memorize that fact. Okay? No way around that. And for cotan, remember that the 5 values in one cycle in your parent table go from there to there, from 0 to pi. And in between, you have pi over 4, you have pi over 2, you have 3 pi over 4. So those are the 5 values for cotan. 0, pi over 4, pi over 2, 3 pi over 4, and then pi. That's the parent table of cotan. Now in terms of what the y is at each of those stops, it's the value of tan at each of those locations. And so, I mean, it's just something you need to know from the last unit that tan here is undefined. Okay? Tan here is negative 1. Tan here is 0. tan here is 1, and here it's also undefined. And that's because cosine is undefined here. And what is tan? Tan is defined as cosine over sine. So when this is 0, tan is undefined. Cotan is defined as cosine over sine. It's kind of the reverse. So wherever sine is 0, cotan will be undefined. So whereas cotan 0, it's where sine is 0. Where is sine 0? Well, it's not 0 here. Cosine is 0, so this is going to be 0. And, oh no, I'm sorry, I misspoke. Sine there is 0. So this is where it's undefined. Sine, of course, here is 0. Here, the ratio between sine and cosine is 1, positive. Here, cosine is 0, but sine is 1. 0 over 1 just evaluates as 0. This is negative 1. And then pi. Sine is 0, so this is where pi is undefined. Whereas cotan is undefined. Okay, so these asymptotes are going to define one cycle of each of these functions. And you kind of notice some parallels. It goes, for tan, it rises from -1 to 1. For cotan, it falls from +1 to -1. These points. And let's take a look at these points. If we were to graph these points and we put an asymptote here and here, you're going to see that pattern. So the beginning of the period, as we said, is -pi/2. There it is, and that's an asymptote. And the end of the period is pi/2, so you see the asymptote there. This is one cycle of tan, and notice how we said it rises from this point here, which is -pi/4. The value is -1. At pi, it's 0. At positive pi/4, it's 1. But then it just climbs to infinity as it gets closer and closer, as x gets closer and closer to pi/2. So that's tan. Cotan looks like this. You got to really pay attention to the shape and kind of memorize the shape. But it's similar, but you notice how you can call the slope is down, goes down. And the asymptotes don't fall in the same place. The first asymptote is at x equals 0, because that's the beginning of the period, as you tabled out. And the end of the period is pi. So there's kind of this falling shape for cotan. And again, the period is all positive. You're not dealing with negative kind of locations on the unit circle. It goes from 0 to pi. But another fact to just know is that the period of tan and cotan is not the same as sine or cosine. They're 1 pi in width, not 2 pi. Now I'm going to table out and draw the graph of cosecant x. In another video, I do secant of x, and but it's a similar method, and it's really kind of it's artistic. You can kind of put it that way. It's very visual, And the trick is to not graph this or table this out directly. You're going to do it indirectly. The most important step is to recognize that cosecant is the reciprocal of sine. Secant and cosecant are reciprocals of each other. So it's the funny thing that happens with the C and the S, right? So believe it or not, in order to graph this, we're going to spend most of our time graphing this, but then noting some characteristics of this graph, which will allow you to then correctly graph this, okay? So you know how to table this out. Let me just do it. So after you've done the sine table, all you're going to want to do to remind yourself as you draw this is that wherever you see 0 or y equaling 0, since cosecant is 1 over sine, this is where you're going, the value of cosecant is undefined. And therefore, this is where you're going to draw an asymptote. Okay? So just note that. And I'm going to blow this up because I need more room. So let's draw sine first, okay? And actually, I'm going to keep going. I'm going to go all the way up to 4 pi. And you'll see why in a second. I'm going to continue by going halves. I know this is 4 halves, so this is 5 halves, 6 halves, 7 halves, and then 4 is, of course, 8 halves. These mean the same thing. Okay, so let's draw a sine. Okay, here are our 5 values, and I'm going to connect it. It looks like a very nice looking normal sine curve, and then we're going to just continue that pattern for one more period of sine. Okay, so wherever sine touches the midline, which in this case, the midline is y equals 0. Wherever it touches the midline, like here, you're going to draw an asymptote, like right here, there. Okay. And then, final touch, draw cosecant. And all you're going to do is touch the top of this, draw these like U shapes, okay? And make sure the U shape fills in the space between the asymptotes, but touches the top of the sine curve there. Touch the bottom of that sine curve there. Do that again. Do that again. So technically speaking, this is one period of cosecant, because this is what repeats itself. So one period is technically 2 pi, the standard period. We didn't modify it with any frequency, okay? The distance between the asymptotes is actually pi, because there's an asymptote that splits the period in each case, right? From here to here, it splits right there. So all that I care about for my purposes when you're asked to graph cosecant or secant is that you kind of artistically draw the reciprocal, the cousin of the function, which in this case is sine, and then show me that you know where the asymptotes go, and then draw those hoops. I'm not asking you to calculate any of these values in between and make sure you get the shape of these hoops exactly right. That's a little too much. Okay, let's go to Desmos and see what it truly looks like. Okay, so there's sine, which is what we calculate. And this may have some transformations, although we're not going to make you do much in the way of transformations to this. But regardless of maybe we change the frequency, in which case cosecant will still have the same relationship. Okay, these U shapes touch the bottoms and the tops of sine. In this case, the period has shrunk as we've increased the frequency, but as long as you draw sine correctly, and you know that the asymptotes go wherever sine crosses the midline, there, and you draw those hoops, you're good. If you're asked to do secant actually looks like this, but in order to place these U shapes correctly, you're going to want to draw the underlying, the reciprocal of secant, the cousin of secant first, and then line up those asymptotes. There's a midline crossing, there's a midline crossing, and do your shapes, your U shapes.